Hi guys, welcome back to my channel. So today we'll be talking about Terraform infrastructure as a code tool, which is being developed by HashiCorp, and we will be looking into the following contents today. We will be talking about Terraform basics, Terraform installation on different operating systems, authentication and authorization, and then we'll be doing hands-on. So let's get started. First is what is an infrastructure as code. Then we'll be looking into what is Terraform and why Terraform. So, what is infrastructure as code? Basically, infrastructure as code is a way or a methodology through which you can manage and provision your resources, and these resources could be on cloud. So basically, if you want to spawn an EC2 instance, if you want to spin up an EC2 instance, and you want to do, you can do it manually, or you can use Terraform to spin multiple EC2 instances or multiple resources for you in one go just by writing a Terraform script. You have to write .tf files in order to spin up these servers, these databases, and different different resources can be spinned up with the help of Terraform. We'll look in depth what all resources could be spinned up by the Terraform, and how you can update and edit or modify your resources using Terraform. And some of the benefits of Terraform that we'll be discussing today is Terraform is basically a multi cloud support. So that means a lot of providers can interact with Terraform. So there are around 130 plus providers which can interact with Terraform. So let's go to Terraform website and see what all providers are being given by Terraform. So these are some of the providers that are being collaborated or that are integrated with Terraform. So basically, Terraform is considered a multi-cloud support environment because numerous cloud providers, including AWS, Azure, Google Cloud, works with on-premises infrastructure. And it even works, Terraform even works with on-premises infrastructure. So it is a multi-cloud support, and this flexibility makes it a preferred choice for organization with multi-cloud or hybrid cloud setups. So nowadays, a lot of organizations are choosing to create multi-cloud or hybrid cloud setup. So in that case, it becomes quite a popular choice among different organizations because it provides support to a lot of different providers. It also provides supports to different tools and technologies, and you can see that it has an integration with Helm as well. It has an integration with Oracle Public Cloud, with Oracle Cloud Platform, with Salesforce, and Vault. And it also partners with different providers, and these are some of the providers with which it partners. So if we talk about providers, so there are three tiers of providers that are being provided. So there is an official tier, then there is partner tier, and there is community tier. So these are all the provider tiers that are being supported by Terraform. Next advantage of using Terraform is declarative syntax. So it basically means that Terraform uses a declarative configuration language. So we'll just now look into the Terraform files that we will be creating. And this configuration language that Terraform uses is known as HashiCorp configuration language that allows users to define the desired end state of the infrastructure. So basically, we are declaring what has to be the end state of the infrastructure. This means that user specifies what they want and Terraform figures out how to achieve it, simplifying the management process. So we don't have to tell how you have to achieve the creation of, let's say, creation of a new EC2 instance, creation of a new key value pairs, different kinds of resources that needs to be created. Terraform itself figures out how it is going to create those resources. Then the third advantage is infrastructure as code principles. So basically, by treating infrastructure as code, Terraform brings the benefits of version control along with it. It also brings the benefit of code reusability and collaboration to infrastructure management, making it more efficient, reliable, and scalable. And then the last one, which is state management. Terraform maintains a state file, so that keeps track of the current infrastructure state. This enables Terraform to plan and execute changes only where necessary, so reducing the risk of unintended modifications and providing a clear view of the infrastructure's status. So basically, Terraform provides a versatile use. It has a lot of providers integrated on its platform and has the ability to manage infrastructure across different platforms, which makes it a popular choice for implementing infrastructure as a code among different organizations. And nowadays, organizations are also moving towards using this infrastructure as a code so that they don't have to manually manage create or run the resources, they can do it with the help of Terraform or infrastructure as a code technologies. There are other infrastructure as code technologies as well, like Amazon's AWS cloud formation, and Azure also has its infrastructure as a code technology. But nowadays Terraform is being preferred, because the reason is because it has integration with multiple cloud platforms and multiple several other platforms. Let's look into the Terraform installation. So we will go to this link, developer.hashicorp.com/terraform/install. So you can see that there are different operating systems, and for each of the operating system, it has provided us a way to install it. So make sure that you're downloading the correct binary for the correct operating system. So if we go to Windows, and you have two option, AMD 64 and 386, so download the correct binary. So once you download the binary, you will be getting an exe file in case of Windows operating system, and you have to install that exe file. And then you have to go to your system variables, and you have to define the path where you have kept that exe file, so that next time when you are running the Terraform, your path is already being defined. For Linux, you have to copy these commands and you have to run these commands. So I'll show you the Linux installation just now. And so let's install uh, Terraform on Ubuntu. So we will go to our AWS console, and we will go to EC2. We will create a new instance in a minute, and then we will be installing Terraform on that new EC2 instance. So let's go to our instances, and let's click on launch instance. So once you click on launch instance, you can give the name of your server. So you can say that you are going to create a Terraform server. Then these are different AMIs, and you can select any of the AMI you want. So let's say you select Ubuntu AMI. So this falls under free tier. So whatever we are doing today, if you are using AWS free tier, then you won't be charged anything. And then we will be selecting T2 micro, the default one. For key pair login, you can create a new key pair. You can give a new key pair name. Terraform pair, let's say, and we will click on create key pair. It will actually create a key pair, and it will be downloaded for you. So terraform.pem is the file that has been downloaded for you, which you can use when you will be using SSH to connect to the EC2 instance. At that time, you can use your key value pair, the key that just got downloaded. And then it says create security group. So let's select an existing security group. You can create a new one as well, but since I have a lot of security groups, I can select any one. And then I will quickly click on launch instance. Once I click on launch instance, an EC2 instance will be launched for us, and we are going to install Terraform on that particular EC2 instance. It is taking some time to load, so let it be loaded, and then we'll quickly connect, and we will uh, install Terraform on that particular instance. Okay, so we will click on this connect button. We will select the instance. We will click on connect button. Once we click on connect button, we will be clicking on the connect button again, EC2 instance connect, and we will be using the EC2 instance console command line interface in order to install Terraform. So you don't have to do much. You just have to go here and you have to copy all these commands. So you can click on copy, and so basically it does sudo apt update. So it will update your packages, and then it will install Terraform on your EC2 machine. So it is correctly installing Terraform on your EC2 machine. Okay, so now let's run the command terraform version command, terraform minus minus version, in order to see that whether the Terraform is installed or not, and we will hit enter. So it says Terraform v1.6.4 on Linux underscore AMD 64. So that means Terraform has been installed successfully on our EC2 instance. Let me show you quickly how you can install Terraform on your local Windows machine also. So what you can do is you can download Terraform, and once you download Terraform, this will be the file that gets downloaded, Terraform Windows. And then this is the exe file that gets downloaded. So when we go to Windows, the binary that gets downloaded is this terraform.exe. You run this particular binary and your Terraform will be installed on your local. And what you have to do is you have to go to system variables on path, and then you have to give your path till here in the systems variable. And once you have given this particular path, your Terraform will be full functioning and you can start using it. So let's see. If I go to command prompt and I type terraform minus version, so it will show me that Terraform has been installed, and the version of Terraform that got installed on this Windows machine was Terraform v1.6.4. So now we'll be using this machine in order to connect to our AWS server. In order to connect to our AWS cloud provider, and then we will be spinning up different resources on AWS, and we will be looking a hands-on exercise over here. So let's deep dive into the hands-on. Next topic is before going into the hands-on, let's look into the authentication and authorization that is needed between Terraform and provider. Let's try to understand what does it means, authentication and authorization. So we have Terraform tool over here on our local or on some server, and then we are sending the request to AWS to create a resource. Let's say I want to create an EC2 instance. So what happens is AWS will reply to us. AWS will not authenticate it. Basically, authentication means that it's a kind of verification of the identity of a user or a service. So, whenever we log in into a service, we have to provide our username and password. So, whenever you log in into AWS console, you provide with the username and password. Or whenever you are trying to access a particular EC2 instance through SSH, then you have to provide the relevant key over there. So there has to be some kind of authentication mechanism which shows that you are allowed to access the resources which are going to be created on AWS or any other provider, let's say Azure, Google, or Oracle, anywhere. So you should be an authenticated user and you should have a username or password, or you should have some kind of authentication available over there. So AWS will say you should authenticate yourself. Then the second part comes is, let's say the user is authenticated user, but there is another part which is involved, which is authorization. That is, the user should be authorized, or the user should have the access rights to create that particular resource which we are trying to create on the cloud provider. Let's say on AWS we want to create an EC2 instance, then the user who is trying to create that resource should have the rights or the permissions to create that resource. So whenever you add access to the user, make sure that the user has required permissions to create, update, or delete the resources. So basically, Terraform will send the request to AWS, and then AWS passes the request because Terraform will provide username or password along with the request that it is sending. Actually, Terraform will provide the secret keys which were generated by AWS in order to authenticate itself that it is the correct one, correct user, and it has the rights to create the request. However, we have to make sure that the access credentials that we are providing has the required permissions, has the required permissions to create a resource, to destroy a resource, to modify a resource. Whatever we are trying to do, it should have the correct permissions, as well as it should be an authentic user. So now there could be different ways to authenticate on different platforms. So for example, AWS uses access keys or secret keys to authenticate. So you go to an IAM service of AWS, and over there you will create access keys or secret keys. I will just now show you how you can create an access key or a secret key for a particular user. And GitHub uses tokens to authenticate. So GitHub has a different mechanism to authenticate. Then Kubernetes might use kubeconfig file, and then DigitalOcean also uses tokens to authenticate. So there are different ways, different platforms or different providers allow its users to be authenticated. So we have to keep that in mind as well. Now let's look into our hands-on exercise of AWS plus Terraform. Let's go to the providers. We will click on AWS and we will go to the documentation. And once we go to the documentation, in the usage, you can see that there is a Terraform code that is being provided. So we will be creating an EC2 instance, and for that, if you go to authentication and configuration, you can see that you have to provide your access key and secret access key. So let me show you how you can create an access key and a secret access key. So you have to go to IAM service of your AWS. So let's go to IAM service. Inside the IAM service, for the existing users, we are going to create a secret key, access key and secret key. So let's say I go to this particular user and I go to security credentials, and once I'm in security credentials, I would like to create an access key. So let's say I create an access key for the use case CLI. You plan to use this access key to enable the AWS CLI to access your account. Then you will click on I understand the above recommendation, and finally I will click on next button. So once you click on next button, you have to give a tag value. So let's say I give a tag value as Terraform demo, and then I click on create access key. So once I have clicked on create access key, I will use this particular access key. I will copy this particular access key. So let's say I copy it somewhere with me, this particular access key, and I will also copy this particular secret access key which is showing over here. I will copy it and I'll keep it with myself. So this is a very secret keys, and you should keep it very confidential. If hands someone gets hold of this particular access key and the secret access key, then they can access your account easily. So basically, make sure that no one can get hold of these keys for you. So once you generate these particular keys, now let's create our first Terraform file. So we will go to the folder that we have created, and inside that folder, we will create our first Terraform file. So I will be using VS Code IDE in order to work on my Terraform files. So let's create a new file, this particular folder. So we will create our first ec2.tf file, and then we will hit enter. And for writing the code, we will go back to our Terraform documentation, and I will show you how you can easily write the code from Terraform documentation. Terraform docs, and over here you can see that we have provider as AWS, and the region is US West 2, and then you can provide your access key and secret key over here. So you can copy paste this particular code, and then you can go back to your VS Code, and over here in your first ec2.tf file, you can provide these details. So you can provide your access key which we just downloaded, and you can provide your secret key also over here. So let's copy paste the access key and the secret key. And for region, let's connect to North Virginia region, so that is US East 1. So we will connect to US East 1 region. So let's update that, US East 1, and we will be copy pasting our secret access key and both the keys over here. And once we have copy pasted the keys over here, what we have to do is, next thing is, we have to define the resource that we are going to add to this particular key. So we have added the providers, now we are supposed to add the resource. So the resource that we are planning to create as of now will be our ec2 resource. So let's see, let's go to AWS. These all are resources which could be created by your Terraform. So let's go to EC2. So if we go to EC2, EC2 is basically Elastic Compute Cloud. It is a server service that is being provided by AWS. So something that we want to do is, AWS instance is something that we want to spin up. So we will go to this AWS instance inside a documentation, and we will go to this resource, and inside this resource we will copy the code that is mentioned over here, and then we are going to paste this code in our Terraform file. So once we paste this code inside a Terraform file, now let's get the correct AMI for our T2 micro. Let's create a T2 micro instance type. So we will go and get the correct AMI. So in order to get the correct AMI, you can go to launch instance, and over here you can see that there is an AMI ID. So you can use this particular AMI ID, and if you want to use Ubuntu, you can select that as well, and you can copy this particular AMI ID, and then we will go back to our file and we will be putting our AMI ID over here. So once we have placed our AMI ID, I will also update access key and secret key, and then we will run the Terraform commands in order to spin up our EC2 instance. Now, if you want to see this Terraform file to appear in this particular format, in the colorful format and all the formatting, so you can go to your extensions and then you can install HashiCorp Terraform plugin in order to make sure that the file appears the way it is being appearing. So this is the plugin that you have to install so that the file appears the way it is appearing now and all the formatting is being done for you. So I have installed that particular plugin. Okay, so now we are in this particular folder, and inside this folder, Terraform files folder, we have only one file, which is the first underscore ec2.tf file. Now we will run this particular command, which is your Terraform init command. So it is actually initializing your provider plugins. So basically I will show you what it means. Initializing the provider plugins means it will actually create a plugin folder for AWS inside your this particular directory, Terraform files directory. It will create a folder and it will install and keep all the AWS relevant plugins or all the provider relevant plugins inside that particular folder. I will show you that in a bit. So now our Terraform init command has executed. Now let's try running the command Terraform plan. Sorry, I misspelled Terraform over there. So you can see that this particular command Terraform plan, it actually shows you what is the plan, what it wants to install, and what all things it wants to create, and what all things it wants to modify or delete. So it says plus create, so that means it is going to create this particular resource on AWS instance, and it will name the resource as web. The resource will be named as hello world. It will be tagged as hello world, and an EC2 instance will be created. Now, the next command, in order to execute the creation of this particular Terraform resource, the next command that we are going to give is Terraform apply. So, this command will actually show the plan as well as it will also execute the plan if you will say, yes, I want the plan to be executed. So, it is asking you that. Do you want the plan to be approved? So if you want the instance to be created on your AWS cloud platform, then you can type in yes over here, and once you type yes, then an EC2 instance has started creating and it will show a message that EC2 instance has been created. So it is still creating, that's why it is showing the update as still creating. So it took around 20 seconds to create it. It is still creating. Okay, it is taking some time to create the EC2 instance, and finally it has created. So let me show you the EC2 instance that it has created. Let's go to our instances and let's see if an instance has been created. So you can see that hello world. So this is the new instance that has been created just now after running our Terraform code. So this is the instance that just got created. So how easy it was to create an instance. We just wrote 6 lines of code and it actually created a EC2 instance for us. So let's say you have to create hundreds of EC2 instances, or you have to create hundreds of a resource. You don't have to go manually and click every time and create those resources. You can just use this particular file and you can create the EC2 instance or whatever resource you want to create on whatever provider you want to create it on. So when we started creating the file, the only file that we created was first underscore ec2.tf, However, Terraform has created all those files for us. So when we do Terraform init command, so in that case it creates this particular folder, .terraform folder, and the provider for which you want to create the resources, it creates a relevant plugin or the relevant file for that particular provider. So you can see that it has created aws uh, AWS plugin file over here. So this is the plugin file that got created. So this is around 300 MB of file that got created, and this was just created with the help of Terraform init command. Just now I will show you that how to create a similar plugin file, or how does Terraform init command creates a similar plugin file for an Azure resource. So let's see. Let's try for Azure, another cloud now. So we will add a small piece of code for Azure. So in order to configure Azure, we are going to add the provider, a new provider. So like we added for AWS, similarly we will provide the provider for Azure, which is Azure RM. And these are some of the little bit configurations which we have added. So provider, it remains same in all the cases, and resource is something that keeps changing whenever you want to create different resources. And name is something that keeps changing for whatever resource you want to create, update, or delete. Now let's try giving Terraform init command. For giving the Terraform init command, uh, it should actually create an Azure RM plugin as well, similar to the AWS plugin that I have just shown you. So let's try running Terraform init command once again from the same folder. So it did. It says that it is installing plugins, and let's see if it has installed Azure plugin for us or not. So let's go inside that particular folder and see it has installed Azure plugin for us or not. Now, if we go inside .terraform folder and we go inside providers, we go inside HashiCorp, we can see that there is an Azure RM folder that just got created once we ran the command. We ran the command Terraform init. So basically, it downloads the relevant providers plugin, and it keeps inside the .terraform folder when you run the Terraform init command. So that's it for today. I hope you enjoyed today's video and this video was informative for you. So if you liked the video and it was fruitful for you, give it a thumbs up and please subscribe to our channel. Thank you. Bye bye.